Welcome to the Environmental Product Declarations, Worthless or Priceless. My name is Richard and I'll be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we will conduct a question-and-answer session. Please note that this conference is being recorded. I would now like to turn the call over to Mr. David Green. You may begin.
Thank you, Richard. Good morning, good afternoon, and good evening to all those that are participating in the call today. Thank you for taking the time. My name is David Green. I am an Applied Sustainability Specialist with BASF, and I'm going to walk you through a presentation on environmental product declarations. As noted, worthless or priceless. So there's a lot of questions around this particular issue, and I hope that we can clarify some of those today. We'll take questions and answers or questions at the end of the presentation, so I'd appreciate it if you'll hold still till then. Today, we're going to talk about environmental product declarations and the fact that they are and can be quite confusing. Give you a simple example or a term of environmental product declarations and what exactly they are, and why do we need EPDs, or why are they being requested by architects and engineers. A key component of an environmental product declaration, or EPD, is a life cycle assessment. We'll go through a brief understanding of that to capture some of the information. The process involved in developing an EPD and the complexities associated with that process. Once you may receive an EPD, it's somewhat important to understand what you're looking at. And so we'll have a few examples of how you can compare the results of an environmental product declaration to some practical equivalents or everyday evaluations. A comparative life cycle assessment approach, which is a little bit more than just an environmental product declaration, that incorporates comparative analysis so that one can see the alternative solution that may be the best selection. And then we'll have some questions and answers. So let's start with the difficulties in understanding what an environmental product declaration is. There's a number of terms that go into an EPD as well as acronyms, and you can see on your screen a number of those acronyms as well as statements. And you may know many of those or you may not know any of those, but regardless, it can be a very challenging and daunting exercise to get through an environmental product declaration. So an EPD is based on an ISO standard, 14025, and the basis behind this is that this standard establishes the principles and specifies the procedures, and that is really the important component. It specifies the procedures on how to develop an environmental product declaration. So under the standard, the ISO 14025 standard, there are actually a number of different labels and declarations that can be developed, and it's important to note which one we're dealing with. And you'll see the blue circled item type 3 EPD, which I'll get to in a moment. So I want to explain the first few so you're familiar with those. A type 1 label, as you'll see on your left-hand side, is actually a label that follows a certain protocol, such as Energy Star. And so if an item, say an appliance, meets Energy Star requirements, then they can put the Energy Star label on their appliance. Forest Stewardship Council would be another type of label that could be affixed to a product based on a standard. So type 1 labels are based on standards that need to be met. Type 2 or unverified labels are, as they say, self-declared. So a manufacturer may claim that their packaging products contain recycled content, or perhaps their manufacturing process utilizes renewable energy. And so they have the ability or opportunity to declare that on their packaging or within their marketing information. Again, unverified, but it's a type 2 type declaration. They should require some type of documentation to verify their claim. However, it's not following any particular protocol. Now, a type 3 EPD, or Verified Environmental Product Declaration, follows the standard, as I mentioned, ISO standard, and that's for the development of the life cycle assessment. In addition to that, it then requires a program operator and verification of the life cycle assessment as well as the finished solution. So a Type 3 verified environmental product declaration has a number of different protocols to follow, as well as standards. Other declarations could be things such as carbon footprints, safety, compliance, as well as things such as organic food. But we're only going to talk about the Type 3 EPD today. So in simple terms, an EPD is very similar to a nutrition label that you'll see on various components that you consume. Could be soda, could be cereal, or even a candy bar. The difference is that an environmental product declaration declares environmental attributes, not nutritional components. As you'll see on this slide, the nutrition label incorporates a number of different measurements, such as serving size, perhaps fat content, or maybe even carbohydrates. And so we're evaluating the products that we consume from a nutritional standpoint. Now, very similar to a nutrition label is an environmental product declaration. In this case, on the right-hand side is an EPD for concrete. The yellow box highlighting on the left is the serving size that you would find on a nutrition label. Very similar to that for an EPD, and concrete is a declared unit, or in this case, a cubic meter. So not serving size, we're looking at a declared unit. On the left-hand side, examples include saturated fats or total carbohydrates. As I mentioned, instead of nutritional components, we're evaluating concrete in this case for total primary energy, or acidification potential, or even eutrophication, or POCP. So there are a number of different environmental attributes that are evaluated, measured, and reported on an environmental product declaration. So why are EPDs of interest, not only to architects, engineers, specifiers, owners, tenants, etc.? The key component here is that an environmental product declaration provides information on products that cause less stress on the environment. The key is that the information generated is not misleading. So the EPD's intent is to eliminate greenwashing, a serious consideration when evaluating products and marketing those products that has to be managed. And so the EPD generates information that's not misleading and is third-party verified. Measuring sustainability, as I mentioned, is a three-pillar objective: economics, environmental, and social. And we have to prevent greenwashing. And greenwashing, as you see here, is the act of misleading consumers. And one key component to preventing greenwashing for products and solutions that go into the built environment are environmental product declarations. To measure and compare environmental impacts is important. And an EPD provides the results for the product based on a life cycle assessment. However, an EPD is a standalone label, much like a nutrition label, in that it doesn't provide you with a comparative result. It merely provides you with information. So if you have a box of cereal that you're evaluating for carbohydrate level, you need another box of cereal as a comparison. Much like an EPD, you would need another EPD to do that comparative analysis. So why are EPDs becoming important to us, and why are we hearing more about them? Well, in the latest version of LEED v4, under the Materials and Resources credit, there is an opportunity to develop environmental product declarations for those products that are installed in buildings and structures. In addition to that, Architecture 2030 is focused on reducing the carbon footprint and energy consumption for new and renovated buildings. And to justify or provide that information, one could use an environmental product declaration. There's also other environmental or EPD programs around the world that are actively participating in the generation of EPDs. Those include countries, as you can see, like Germany, Japan, Norway, etc. And as they become more important globally, there will be more pressure in the United States to develop additional EPDs for products and solutions. Specifically under the LEED v4, the new initiative, under the Materials and Resources component, are different methodologies to acquire points for the particular credit. And the initial one is a product-specific declaration. If you remember the labeling document that I showed you earlier on the slide, we were talking about a Type 3 EPD, but one can generate a product-specific declaration based on life cycle without the third-party verification or the external review. That would be classified as a product-specific declaration and valued as one quarter product. Under LEAD v4, in order to get the point, one needs to have 20 equivalent products associated with EPDs. So the official environmental product declaration falls into two categories as well for compliance. There is a generic or industry-wide EPD that can be delivered, and that would be valued at 1/2 of a product, or a product-specific or company-specific EPD, and that would be valued as one entire product. And so you can see that products that have specific EPDs are valued higher, meaning that for the entire project, the LEAD AP would need less products to fulfill the requirement. So where does everything start? How do you even develop an EPD, or what's the process to get started on an EPD? Well, it begins with what are called product category rules. And so as you can see on this slide is a process for developing an environmental product declaration, and the first step is a set of standards developed for generating the life cycle assessment, or LCA, for products that are similar in nature. So these are the ground rules. These are the requirements. These are your expectations that are necessary to follow the life cycle assessment for a particular product. So to provide you with a couple of examples, if you were going to specify or build 10 identical homes and you used 10 different contractors to build those homes, you would need to provide them with some instructions with the intent of having the same home delivered to you or built for you. And that would require blueprints that would at least make it consistent from the starting point to the end point for how the product should be delivered, or in this case, the home is built. Now, obviously, different contractors may use different methodologies in terms of constructing that building, so each building or each house will not be identical, but the ground rules are there so that the intent is the same. Now, if you're an individual that relates more to sweet things, such as chocolate chip cookies, and you wanted a number of chocolate chip cookies produced by 10 different bakers, then the common denominator in order for them to fulfill would be a recipe. And just because you provided that recipe to those 10 different bakers, you may not come up with the same taste at the end. And the reason for that is different ovens have different temperatures. Not all bakers use the same type of measuring system for 1 cup of flour, say, for example. One may be a little heavy, one may be a little bit short. But the overall intent is to deliver the final product of a chocolate chip cookie, but there will be some variances. So an environmental product declaration starts with those same blueprints or that same recipe, and that's called product category rules. And so those rules are developed so that the end result is the environmental impacts associated with the product. And there may be some variations in those final results based on the data that's available to deliver the life cycle assessment. One needs to be aware that comparing EPDs requires particular nuances that need to be evaluated before an actual comparison can be completed. So product category rules essentially are a set of rules and requirements and guidelines for developing that environmental product declaration. It defines the type of data that has to be collected and measured and reported, and it also includes instructions for how to do that. Now, the data collection methodology is standardized, so the PCR allows for a comparison, but as I mentioned, an EPD is not a comparative analysis. It's a standalone label or evaluation of a particular product. To give you an example of product category rules that are actually available today, you can see that they cover a wide array of different products, components, and even fruits and vegetables and office and home equipment. So they're not specific to construction components. They can actually be developed for all kinds of different materials, products, and solutions. The next step in an environmental product declaration process is to develop the life cycle assessment, the inputs and the outputs associated with the manufacture of a particular product. So the LCA is required to follow the ISO standard, but some background information on life cycle inventory can be important for a better understanding. So back in the day when we began manufacturing products and were removing raw materials from the ground to develop those products, the biggest concern for manufacturers was the availability of raw materials and the availability of energy to run the equipment or process those raw materials into a finished product. But as we generated or removed those raw materials and processed the necessary raw materials for energy, we also generated waste in terms of solids, liquids, and gases. So the two primary concerns relative to production and incorporated into life cycle assessment is conservation of raw materials and pollution caused by the extraction and manufacturing process. So what do we know? Well, we understand that materials are not always overly plentiful and there's a finite supply for not only materials, raw materials, but also for fossil fuels. And if we're not careful in how we consume these materials, that supply could be exhausted. We also understand that historically and even today that the prevention of emissions or the restriction of pollution is based on regulations. And so regulations don't cover everything. The effects of emissions on the planet are obviously gaining awareness, especially with the types of communication mechanisms we have today. So there's a higher level of public opinion about where we stand with regulations and how we manage emissions and pollutions. So regulations aren't the only way to manage factories and manufacturing processes because human activity plays a key role in that. For example, driving habits can impact the carbon footprint that's generated, or how individuals use their air conditioning equipment to cool their homes in the summertime. Recycling practices are also predicated on individuals and their social awareness as well as their decision making. And so regulations aren't going to manage that type of an issue. We also know that there's no such thing as a single environmental problem with one solution. Many things are interlinked, and there's a balancing that's required to manage the inputs and the outputs. And so if we follow the entire system from cradle to grave, from ground to final disposition, we can manage that information and actually go back and make adjustments along that evaluation to make better decisions. So managing the entire process from cradle to grave became known as life cycle assessment. So we're managing all of the information of inputs and all of the outputs along the entire process. Now, back in 1969, the first life cycle assessment was completed for packaging by Coca-Cola. So just based on that, life cycle assessment is not new to us. It's been around for many, many years. So moving forward today, there's a significant mounting wave for life cycle assessment and evaluating not only products but building designs. The LCA is focused on quantifying environmental impacts, and sometimes if we incorporate the costs and the social indicators, then we have a real balance of sustainability. But if we don't utilize LCA and the scientific basis behind it, then we can get into greenwashing, and that creates a problem. So if we focus on specific environmental impacts and we follow life cycle practices and ISO standards, we can utilize that information to develop environmental product declarations, which can be valuable for the value chain. So the next three steps are combined because after the life cycle assessment is completed, now we can use that information to generate the EPD or that environmental product declaration that we're looking for. EPDs in general need to be objective and credible. Credibility comes from the external or third-party verification. They should be neutral in nature. As I mentioned, they can be comparable, but as a standalone, they are not a comparative valuation. They're open to all types of products and services. They're environmentally oriented, and they should be instructive in nature. So an EPD could be used by an organization to redevelop their processes and lower the environmental burdens that are being reported, or they could be used by architects and engineers to make decisions on products they have at their disposal. The basic guiding principles behind EPD programs are that they're voluntary. They're not a mandatory requirement. LEED v4 is not a mandatory initiative. It is voluntary. Just like IGCC, although its code is voluntary code, as well as Architecture 2030. Those are all voluntary programs, so the EPDs associated with those are voluntary. They need to be transparent so the information generated can be evaluated effectively. They should be accessible to anyone that's interested, based on science. The specific information that generates the EPD, in other words, if a concrete producer provides mixed designs for a concrete EPD, that information needs to remain confidential. We need to protect the integrity of products that are developed by manufacturers, and they should be cost-effective. As the market becomes more aware of EPDs and more are generated, the current cost for EPDs will be driven in a downward direction. Currently, they're fairly expensive, but we're also new into this proposal. So in a more simple way, the road to an EPD starts with developing or generating product category rules. Those rules are publicly reviewed, and once adopted, then one can conduct an LCA to generate the information necessary to provide the environmental product declaration. Once the EPD is generated, the formal document, then it needs to be verified by what's called a program operator. The program operator manages not only the product category rules, but all of the submitted EPDs to make sure that they meet the requirements of those rules. At that point, the EPD can be officially registered with that particular program operator. So an EPD in general has three main components. It has the description of the company and the product. It has the environmental results or impacts. And it has the particular third-party or critically reviewed organizations and the specific standard that it meets. So if we look at an EPD and summarize it, it starts with a PCR, product category rules. Those are developed. From the product category rules, one can generate the life cycle assessment, and then the life cycle assessment results are used to populate the environmental product declaration. So this process in a nutshell looks simple on paper, but can take quite a bit of time to get completed. An example of a concrete environmental product declaration would be here. And what you'll see on the left-hand side in the slightly highlighted box is actually the environmental product results or the environmental impacts. And those are very similar to the nutrition label that you saw earlier in the presentation. So as you'll note in the highlighted box, there are operating impacts and there are environmental impacts. And based on the rules that were written, both of those areas need to be presented in the formal EPD. In addition to that, though, the EPD is owned by the manufacturer, and therefore, the manufacturer should provide information about their organization. They can utilize it to market their products, but it also should include the location of the particular plant or manufacturing site or region, as well as a website and a phone number. Now, some of the more important things would be within the EPD itself, and this information is important to understand because some of it plays into meeting the requirements for LEED v4, and some of them meet the requirements of an ISO Type 3 EPD. So in the bottom, or generally on a particular page, will be the product category rule information, Basically what that means is the EPD is generated from a specific set of product category rules. Now, since a number of product category rules could be out there, EPDs could use different PCRs to generate their information. And so if one was to compare EPDs, one of the first things they should check is to make sure those two EPDs are generated from the same PCR. Then the LCA is completed, as I mentioned earlier, and that requires a critical review or third-party external evaluation. That individual or organization should be noted within the EPD. Once the EPD is generated, then it needs to be verified, and it gets verified to the rules. It gets verified back to the PCR, and therefore there is another organization that reviews the EPD to make sure that it meets the rules. The declaration holder is the owner of the EPD or the manufacturer, and the validity is usually 5 years on an EPD. And then the program operator is the manager of the process. They manage the product category rules, they manage the submitted EPDs and make sure that they meet the requirements, and then they will register that EPD once completed and provide it with an official stamp. In this case, in the lower right-hand corner, you'll see a stamp NSF. That would be the program operator for this particular EPD. So as I mentioned, EPDs are very similar to nutrition labels. For the concrete EPD in particular, there are operational impacts that need to be evaluated and reported, and environmental impacts that need to be evaluated and reported. So if we look at some of the operating impacts, those would include energy consumption, fuel consumption on site, water used for batching concrete, additional consumptive water used for equipment and vehicle washing, and then the disposal of any wastes on site. Now, we're not looking at gross numbers to be reported, but these numbers would be reported per cubic meter of concrete. And so you could quickly evaluate two EPDs if they're managed under the same product category rules and evaluate the operating results for a particular process to see what their energy consumption per quantity of material produced equates to. On the right-hand side are the environmental impacts. These are primarily the impacts that you'll see on all EPDs, but specifically for concrete, they're also noted here, and they include total primary energy, climate change, ozone depletion, acidification potential, eutrophication potential, and photochemical ozone creation potential. And many people don't have a clue what most of these impacts mean or even how to relate to them. So I'm going to provide you with a little bit of insight into understanding what they are and perhaps putting a correlation to them. So on the left-hand side, you'll see the impact category. In the center is the more common term. So climate change, global warming, you may be more familiar with. Carbon footprint is a component of that. Acidification potential, commonly known as acid rain. Ozone depletion, if you're familiar with the term ozone hole or the depletion of our ozone in our atmosphere, that would be related to ozone depletion components. Eutrophication is a challenging word. It is the essence of too many nutrients that enter waterways, generally phosphorus or nitrogen. As those enter the waterways, they develop more plant life, and if that plant life consumes or takes up space and also consumes some of the nutrients in the water, then the aquatic life may not survive, and then once the aquatic life starts to die off, then we end up with what we call dead waterways. Photochemical ozone creation, commonly known as smog. On the right-hand side, you can see what the units are in terms of reporting those particular impact categories. To give you an idea about climate change and maybe how we can relate it to things that are more understandable, first of all, global warming potential or climate change is more than just a carbon footprint. And many times you'll hear that it's just CO2, but it's actually evaluated by CO2 equivalents. So it's those things that impact climate change, such as carbon dioxide being one, methane, halogenated hydrocarbons are additional components that impact climate change. And so these have to be summarized and compared to CO2 as the baseline to come up with the final result. So beyond the chemical parts, if we're looking at climate change and the CO2 equivalents, you can compare that to, for example, the same CO2 equivalent that's combusted in a gallon of gasoline. And so if we look at the example of how much CO2 is generated from a cubic yard of concrete, generally speaking, it's about 400 pounds of CO2. So if one was quickly to correlate that, they could say it's about a gallon of gasoline is equivalent to 19.6 pounds of CO2. If we round that up to 20, you can see where the comparison is. What's nice is these practical equivalents are available from the U.S. EPA website under the Clean Energy tab. And so one can quickly go to that tab and do a correlation between some of the results and some practical equivalents. Another equivalent here you can see is that an acre of mature forest sequesters about 2,700 pounds of CO2 per year. So we could then determine how many acres of forestry were required to sequester the production of a cubic meter of concrete. Acidification potential, or acid rain, also has a practical equivalent. Air conditioning units actually give off SO2. And so if we were to evaluate acid rain component from a particular environmental product declaration, we could compare that to the number of air conditioning units in the United States. Summer smog, or POCP, the definition here is the chemical reactions brought about by light energy of the sun, and the reaction of the nitrogen oxides with hydrocarbons in the presence of sunlight forms ozone. And a practical equivalent to that is how much ozone is generated by an average family car. You can see the number there, and so you could compare the results of an EPD to the number of cars that would be in the United States. Eutrophication, as I mentioned, is over-fertilization of waterways. One could compare that to, say, for example, fertilizing your yard. And a concrete mix generally does not impact eutrophication significantly. It's a fairly small number. And so you could see, for example, in this practical equivalent, 0.25 pounds of nitrogen from a cubic yard of concrete would be equivalent to fertilizing 165 square feet of your lawn. Water is a little easier to understand. Consumptive water is that water which gets used, obviously, and so we could compare that to, say, washing machine loads or showers taken or even dishwasher loads to give it some semblance and understanding, and even relate that to all levels of academia. And finally, a couple other two are energy consumption, environmental impact. As you can see here, an average home uses about almost 13,000 kilowatt hours of energy on an annual basis. And an average individual actually generates about 5 pounds of solid waste per day. So now we can compare that to humankind and our generation of solid waste, or how our homes are heated and managed from an energy standpoint. So if we put it all together, we can say that to develop an EPD, it starts with product category rules. If product category rules don't exist, then a formal Type 3 EPD cannot be generated. But once those rules are created, then one can develop the life cycle assessment, and the LCA analyzes the data based on those rules. The results of the LCA are then used to populate the Environmental Product Declaration, or EPD, and that's the summary document. Once the EPDs are developed based on the same PCR, then they can be used to compare products, but as a standalone, they're not a comparative result. And an EPD must be verified by an independent third party. So one thing to take into consideration is, as you're looking at the environmental impact categories and those results, is different regions may have different values to those impact categories. So an EPD, say, in Northeast or Midwest, from a consumptive water standpoint, may not be as important as an EPD result in, say, Arizona or the Southwest United States, where water isn't as prevalent. And so EPDs are not always judged the same in all regions, and each region may have a different attribute that they're concerned about, and so that needs to be evaluated effectively. Remember, from the beginning of the presentation, we noted that there's no such thing as a single environmental problem or a single solution. So if you're only looking at one particular environmental impact category, you risk missing other impacts that may have higher problems associated with those. So one should always at least consider all the environmental impact categories before making a final decision. Now, since the EPDs are a standalone, non-comparative evaluation from an environmental standpoint, I want to show you another tool for comparative LCA, which actually provides some solutions in an easier-to-read format. As I mentioned earlier, sustainability is the balancing of the economic, environmental, and social impacts for a product or a process. We need to balance those to make the best solution or decisions based on the results. One can have the most environmentally preferable solution, and yet it may be economically impractical for anyone to buy. And so is that solution really effective in terms of building or constructing a particular project or solution? If no one buys it, then it's really not viable. And so we need to balance those impacts to come up with the most sustainable solution. Eco-efficiency analysis is a term that was developed by the World Building Council on Sustainable Development. And it is a comparative life cycle assessment which incorporates not only the LCA component, but also a cost component so that one can find the balance between economics and environmental impacts. An eco-efficiency analysis can be third-party verified. There are a number of organizations around the world that have evaluated this methodology and confirmed it. One is TÜV over in Europe. Another is NSF International in the United States and North America. Eco-efficiency analysis or comparative LCA must follow ISO protocol, so it meets those requirements as well. It follows the life cycle assessment from cradle to grave for all of those inputs as well as emission outputs. And for concrete, an eco-efficiency analysis can evaluate much like an EPD does from a cradle-to-gate standpoint, from raw material extraction through the production of the concrete itself. So an eco-efficiency analysis uses the same cradle-to-gate objective. One of the additions is that it incorporates costs. You can see a list of costs here that could be associated with the life cycle for a product or process. The more costs that are included, the better the results. An eco-efficiency analysis actually evaluates more than an EPD. It not only incorporates emissions from air, water, and land, and the consumption of energy, but it also incorporates risk potential associated with accidents and injuries, toxicity potential, not only from the manufacturing process, but also during the application and use phase, as well as it evaluates the transformation of land for the manufacturing site for the production of a particular product. You can see here the emissions are broken down into solid, air, and water, and air emissions incorporate many of the same environmental product declaration impacts that we talked about earlier. An eco-efficiency analysis, very much like an EPD, starts with data input from the manufacturer, goes through a computer analysis, and then finishes with a final report. The mixes are developed and reported. An alternative evaluation is then done with the eco-efficiency analysis, so one can compare a number of different concrete mixes for this example and actually evaluate which one is the most sustainable alternative. So if one can look at the ecological fingerprint and the 6 environmental impact categories, if you understand that the lowest environmental impact is at the axis, or the origin, I should say, of these axes that intersect, the highest environmental impact would be at the outer point of each one of those axes. One can quickly see which of the particular alternatives impact the environment the most. Taking each one of those axes and breaking them down into bar charts, you have the opportunity to see what is the most impacted component that generates the final product. In this case, the green or green color you see for CO2 equivalents or climate change, the biggest impact there is the cement that's used to manufacture the concrete. If we lower the cement content without impacting the structural integrity of the concrete or the design specifications, then we can start to develop more sustainable solutions. Using the practical equivalent approach, one could then take those alternative mixes and evaluate them from, for example, a climate change or a CO2 footprint standpoint, and compare those results to see which has the preferable solution. Same practical equivalence could be used for energy consumption as well as water consumption. When you combine the environmental impacts with the total costs of ownership, you generate what's called a profile. And from this profile, the objective is to move to the upper right-hand quadrant. And if that solution is in the upper right-hand quadrant, it has the lowest costs associated with the lowest environmental impact. The axes are a little bit counterintuitive, where the lowest impact for the y-axis is at the top, and the lowest cost along the x-axis is furthest to the right. So moving in the upper right-hand quadrant provides the most sustainable or eco-efficient solution. In this case, one could quickly evaluate 5 concrete mixes to determine the results which are most eco-efficient, which is much different than an environmental product declaration, which merely shows one particular result. The benefits to eco-efficiency is that it provides alternative solutions and answers over and above just one particular label. Those results can be used for strategic decisions in the investment sector or in specific R&D components relative to developing products. It can also be used to substantiate the sustainable claims for a product or a solution. So that can be part of a marketing strategy, and that information can be delivered to customers, users, tenants, and owners, etc. It also has good output that can be used in dialogue with stakeholders and government and non-government entities. So it has an impact along the entire value chain in terms of providing critical information for environmental and economic impacts. EPDs can be valued from the A&E community. They can evaluate it for trade-offs between impacts and performance. It can relate to individual claims such as water consumption, as I mentioned earlier. From a regional standpoint, one may want to focus on a particular area as that may be more impactful for that particular region. It also provides the opportunity for the A&E community to compile those eco-labels or EPDs into one document for comparison. For the manufacturer, they can use those results as a baseline to develop new products or new solutions that are less impactful. They can use that to market themselves to their customers and along the value chain to provide a differentiation. And it does provide that baseline measurement. So today, hopefully, we got a little better understanding of environmental product declarations and how they're being deployed in the marketplace, how they're being requested, how they're being hopefully used, and how they're created. The importance of life cycle inventory in terms of that entire EPD generation. the overall process and the challenges associated with the time constraints, costs, and third-party verifications to develop the final EPD. Some comparative analyses that you could use when evaluating EPDs if you are in that position, and another alternative known as comparative life cycle assessment. So finally, what is an EPD worth? From an architectural standpoint or a LEED v4 AP, we have to ask ourselves, the average cost for a cup of coffee associated with researching sustainable products, let's say $2.38. Now, if you need a little bit more caffeine, it may be upwards of $3.45. If you're really struggling with the research that needs to be done, you're going to have to probably incorporate some additional headache medicine. That can be a little bit more towards $10. But if a LEED AP misses their certification by 1 point because they didn't have that particular EPD, that can be an extremely expensive proposition. So realistically, when using EPDs and developing EPDs, one has to look at the results and the value that's associated with them. And when we can provide environmental impact results in a scientific basis that has credibility to the environment, we can all win. So the value for that EPD is priceless. So that concludes our presentation today. I appreciate everyone that attended. And at this point, I think we could open it up for any questions.
Thank you. We will now begin the question and answer session. If you have a question, please press 0, then 1 on your touch-tone phone. If you wish to be removed from the queue, please press 0, then 2. If you are using a speakerphone, you may need to pick up the handset first before pressing the numbers. Once again, if there are any questions, please press 0, then 1 on your touch-tone phone. Standing by for audio questions. We have a question online from Jay Shilestone. Please go ahead.
I missed part of the presentation. Has the eco-efficiency been specified or required in the U.S., or is it in use primarily in Europe right
now? The eco-efficiency is not necessarily been specified, but it is a third-party life cycle assessment that has a methodology that's available for anyone to generate. That is through NSF. It has been specified in one project in Florida that I am aware of. I'm not sure if there are any additional specifications that have been written based on comparative LCA, but that one is one that I'm familiar with.
Once again, for any questions, that's 0, then 1 on your touch-tone phone. And I see we have no audio questions at this time.
Well, again, I thank everyone for participating. If there are further questions, please feel free to reach out. My name is David Green again. My email is david.r.green@basf.com. And I appreciate your time today and look forward to additional presentations in the future.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating. You may now disconnect.